Assalamualaikum and good evening. Okay, my name is Muhammad Shafiq bin Hamsani. My matrix ID 191291929, and I am from class RY31, and this is my uh, presentation video for PLT 203 Electronic 2 for my CAA 3. So for my introduction, the based on the topic that we apply in my project, which is the voltage regulator. And a voltage regulator is a system designed to automatically maintain a constant voltage level. A voltage regulator may use a simple feed-forward design or may include negative feedback. It may use an electromechanical mechanism or electronic component. Depending on the design, it may be used to regulate one or more AC or DC voltage. The material that I use in my project is the first one: breadboard, power supply, resistor, valuable resistor, operational amplifier 741, the Xeno diode, bipolar junction transistor, NPN type, and the last one is multimeter. So we look for the method that I apply for my project which is the first one, the step one. I need to design the circuit and set up the component. Okay, the first one we see my power supply. I set 15 volt, 5 ampere. My R3 resistor 3 I set to 90 kilo ohm. My Xeno diode I set to 6 volt. R1 resistor 1, resistor 2, and variable resistor uh, I set 1 kilo ohm, which is the three value of R1, R2, and RL is the same value, which is 1 kilo ohm. So step 2, I will run the simulation based on my schematic diagram in the Tinkercad. And the last step, step 3, I will see the result, and I will do my report based on the result of my simulation. So let me see the result. Okay, the control element in the circuit is a transistor in series with the load. This is the transistor, which is I use the NPN type of BJT, which is it will series with the load. In our theory, we call the load is Q1. Then we see output sample circuit will sense a change in the output voltage. Sample circuit in my project is referred to R1 and R2. Then the error detector compares with the sample voltage with the reference voltage, Xeno voltage Vz. The error detector is in the area of operational amplifier, so it will function to compare the the sample voltage with the reference voltage. Reference voltage is referred to the Xeno diode, and then Xeno diode set as the reference voltage for the non-inverting input of the operational amplifier, and any change in the output are feedback to the inverting input of the operational amplifier. The different voltage, or we call it the error voltage, is amplified, and the operational amplifier output voltage is increased. So this is for my calculation. We see based on the calculation, we in order to find the V out equals to 1 plus R1 over R2 times with the Vz, refer to the Xeno diode. So as I mentioned before, I use the same value of R1 and R2, which is 1 kilo ohm. This is 1 plus 1 over 1, which we equal to 2, and divide with 6 volt, and we got 12 volt. And this is my result based on my simulation from Tinkercad, and we see I got the same value from the multimeter and the calculation. And the last one for my discussion, the series voltage regulator or series pass voltage regulator use a variable element placed in series with the load. By changing the resistor of the series element, the voltage drop across it can be varied to ensure that the voltage across the load remain constant. And the advantage of series voltage regulator is that the amount of current drawn is effectively that used by the load, although some will be consumed by any circuitry associated with the regulator. Unlike the shunt voltage regulator, the series regulator does not draw the full current even when the load does not require any current. As a result, the series voltage regulator is considerably more efficient than the shunt regulator. And for my conclusion, at the end of this project, I am able to design the circuit of series regulator completely. Moreover, I am able to understand the function and role of each component that I use in the circuit. Okay, that's all from me. Thank you and Assalamualaikum.